Now, before we do that, maybe we do a discussion, which I think is good to talk about, involving the pH of a strong acid. So if you're given a solution where the pH is equal to 1, does it necessarily mean that the acid must be a strong acid? Or another way to look at it is, does it mean that if it is a strong acid, it must always have pH equals to 1? So if it is pH equals to 3, then it must be a weak acid. So is that idea valid or is it not valid? So we want to dispel that idea, or we want to at least talk about this idea. Now, in order for me to show that this is not true, what I'm doing is I'm using strong acid in all instances. I have 3 solutions. All of them are HCl. Alright, this is HCl concentration 0.1. Strong acid concentration 10 to the power of minus 3. Strong acid concentration 10 to the power of minus 5. So you notice what we have is all of them are strong acids, fully dissociated, but because the H plus concentration, or rather the acid concentration is different, so therefore the H plus concentration that we will get will be different. You notice this is 0.1 mole per dm cube. H plus concentration is also 0.1. pH is minus log H plus concentration, pH is equals to 1. So this one no problem, pH 1, strong acid. Some of us will think that. Of course, this is reasonable because if it is a strong acid, obviously this guy, it is pH equals to 1. But you notice when I change the concentration of my strong acid, 10 to the power of minus 3, H plus concentration will now be 10 to the power of minus 3 because it is fully dissociated. The pH, if you go and work it out, it is no longer equals to 1. This guy pH is equals to 3. Correct? Because the H plus concentration changes. And if you have this concentration for HCl 10 to the power of minus 5, you can work out the pH for this guy to be pH 5. So is it true if I tell you 2 solutions, one is pH 1, one is pH 3, so pH 1 must be strong acid, pH 3 must be weak acid. Is that true or is it not true? Now you realize that it's not entirely true, right? Because I can easily have both strong acid with different concentration. I can have one is pH 1 and one is pH 3. So it's not true that if it is pH 3 must be weak acid. The idea is not true. So please keep this in mind because some of us still have this idea. In fact, in other parts of H2 Chem, especially in periodicity, we still use that idea. Oh no, if I form HCl, it is a strong acid, so therefore pH is equals to 1. So if I'm forming something which is a weak acid, so therefore pH is equals to 3. We still use this in other parts of the syllabus, implying that if it is a strong acid, then the pH needs to be very low, and if it is a weak acid, then the pH has to be higher. But in ionic equilibrium, this idea we have to clarify, the pH is dependent on the concentration. So this is very, very important. You notice what we have is all these guys are strong acid, but the pH is different because the concentration is different. So please don't have this idea thinking that low pH must be strong acid. Need not be true. High pH must be weak acid, also need not be true. You won't say that it's totally false, right? We say that, okay, maybe, but we have to consider the concentration of the acid. So for this exercise that we have done previously, when I calculate this, it is true that if I compare these two guys, the one with a higher pH versus the one with a lower pH, the weak acid has the one with a higher pH, strong acid has a lower pH. This is true only when I'm comparing both acids with the same concentration, then this is a fair comparison. If the concentration is the same, alright, it is true that a strong acid will give me more H plus in solution, so the pH will be lower. Weak acid will give me less H plus in the solution, so therefore pH will be higher. This is only true if the concentration of the acid is given. But if they never give me any concentration, they just tell me, oh, pH 1, pH 3, then some of the things in terms of conclusion that we can have will not be so straightforward because we don't have the entire picture. So please keep this in mind. Only looking at pH, it is not reliable to determine strength. So we actually have to compare H plus concentration versus the acid concentration. So please keep this in mind. Okay? Because this misconception is fairly common. Again, the reason is because in other topics, especially for inorganic chem, you still have the tendency to think that, oh, strong acid, pH 1, then weak acid, pH 3. So we will still have the tendency to answer questions in this way. So when we do ionic equilibrium, it can give us a little bit of a problem here because it starts to contradict some of the things we've talked about or we are using in inorganic chem.